We hear a ton about AI these days. A lot of it is just hype. But today, we're going to cut through all that noise. We're going to focus on something really practical, something that's already happening right now. How AI is being used as this silent, super effective tool to hunt down and just eliminate massive amounts of energy waste. So let's get into it. Let's see how this digital detective is already on the case. Okay, so this isn't some far-off future idea. This is real. This is what UPS actually did. It's the perfect way to kick things off because it shows you exactly what we're talking about. Using machine learning to find efficiencies on a scale that's, well, it's just impossible for a human brain to wrap itself around. And this one little change, it saves the company hundreds of millions of dollars every single year. Now, let's bring that huge number from UPS back down to earth, to something a little more relatable. 30%. That's how much energy, on average, is completely wasted in a typical commercial building. I'm talking lights left on and empty floors, HVAC systems blasting when no one's there, different systems literally fighting each other. It's this massive, invisible drain on resources. So our first mission really is to get to know the villain of our story. We're talking about energy waste as this invisible thief, right? It's this hidden cost inside our operations that's just quietly bleeding budgets and pumping out emissions, all while adding absolutely zero value. And you want to know where this thief likes to hang out? Well, take a look. Globally, industrial motors chew up over 40% of all electricity, and building operations, they take another 30%. These two massive slices of the pie, that's where the biggest opportunities are. That's where we can make a real dent. And this chart just nails the point home for buildings. Just look at that second bar. For every single dollar you spend on energy, about 30 cents is basically being set on fire. It's just gone. And this isn't because the equipment is old or broken. No, it's an intelligence problem. The system is just not being run smartly. Which, of course, brings us to the hero of the story. And we're not talking about AI as some sort of magic wand. Think of it more like a specialized digital detective, a tool that is perfectly built to sift through mountains of data and find the tiny clues that lead us right to that hidden waste. So, how does this digital detective actually do its job? Well, it's all about finding patterns. Machine learning models look at thousands of different data points all at once. Things like the weather forecast, how many people are in the building, traffic patterns, temperatures, you name it. It finds these subtle connections that we would never see, and then it uses those patterns to make tiny, nonstop adjustments 24/7 to keep the whole system running as efficiently as possible. All right, enough of the theory. Let's look at the cold, hard facts. We're going to crack open the case files on some major companies that have already put this digital detective on the job and, spoiler alert, are seeing some pretty incredible results. We started with these guys, so let's dig in a little deeper. I mean, the sheer complexity of what UPS does every day is just mind-boggling. Trying to find the single best route for thousands of drivers making millions of stops, for a human planner, that's not just hard, it's literally an impossible task. But for their AI system, which they call Orion, it's just a giant puzzle to be solved. And the result? 10 million gallons of fuel saved. Annually. That is not just a rounding error. It's a huge cost saving. And it also means 100,000 metric tons of CO2 that's not going into the atmosphere. Okay, our next case comes from Google. Now, data centers are the engine of the modern internet. But wow, are they power hungry? A huge chunk of that power goes to one thing, keeping them cool. And here's the funny thing. The rise of AI is actually what's driving the need for more data centers. But it turns out, AI is also the key to making them way more efficient. The big difference here is the shift from being reactive to being predictive. Before AI, you just set the cooling systems to some safe, static level, and you'd usually overshoot it just to be safe. But with AI, the machine learning models are constantly predicting what the heat load is going to be and then adjusting thousands of little settings in real time to deliver the exact amount of cooling needed and not a single drop more. And the impact? It's just stunning. Google's own AI cut the energy used for cooling its data centers by up to 40%. And get this, they did it with zero new cooling equipment. It was purely an upgrade in operational intelligence. So let's bring this all the way down to the office buildings that we all work in. The big problem here is just inertia. You know how it is. The HVAC schedule gets set once, and then nobody touches it for years. The set points are fixed. The system has absolutely no idea if it's a holiday, or if everyone left early on a Friday, or if a surprise heat wave is rolling in. And even on a much smaller scale, the results are obvious. You look at smart thermostats like the Nest, which uses pretty basic machine learning, and they consistently save people about 12% on heating and 15% on cooling. I mean, for that kind of tech, the payback is usually less than 2 years. It's a no-brainer. Okay, so we've seen the evidence, we know this works. The big question is, how do you actually start thinking about this for your own organization? Let's turn what we've learned into a simple, actionable playbook. All right, here it is. A simple, 4-step guide. First, target your big energy hogs. Go after the HVAC, the big motors, the vehicle fleets. Second, and this is crucial, you can't optimize what you can't measure. So getting good, clean data is everything. Third, start with the low-hanging fruit. Tweak the controls on the equipment you already have before you even think about buying shiny new hardware. And finally, number 4, prove it. Measure your savings so you can walk into the finance office with a clear return on investment. So let's wrap this all up by taking a step back and looking at the big picture. Because it's really important to be realistic here and to understand both the incredible potential and the very real challenges of this technology. Look, AI is not a magic bullet. If you're feeding it bad data from broken sensors, you're going to get bad results. It's that simple. And remember, the AI might make a recommendation, but a human still needs to sign off on it and maintain the systems. And we always have to be careful about the AI's own energy footprint. The whole point is to make sure the energy it saves is way, way bigger than the energy it takes to run. So if there's one thing you take away from all this, let it be this. The real superpower of AI in this whole game is its ability to see what we can't. It finds the forgotten setting, the delivery route that nobody thought to try, the tiny invisible leak. It finds the thousands of tiny inefficiencies that, on their own, are nothing, but together add up to a massive amount of waste. And really, that's the question I want to leave you with. We've seen how this digital detective can hunt down waste in giant logistics networks, in massive data centers, and in regular old office buildings. So it just makes you wonder, what invisible waste is hiding in your world? And what could an AI find for you?